Okay, so let's say I am supposed to find the capacitance at terminals A and B, and that's problem 1. And problem 2, the capacitance, and I'd usually say as seen by terminal C and D. So when we start, we'll do A first, and I'm going to do my calculations kind of quickly. So when I'm looking from the point of view of A and B, 5 and I would think about having maybe some sort of source between A and B. And if I had a source between A and B, I can see that this capacitor is in play, and this capacitor is in play, and this one, and this one, and this one. But these two are open. And so if I had a source there, those two would not participate in giving me any more capacitance. And so when I'm finding the capacitance as seen by terminals A and B, the two 5-ohm capacitors at the end over there don't do anything. So this is the same as this. So the first thing I do is I get rid of the ones that aren't relevant. Okay, now I have to remember that capacitors do the opposite that resistors do, because I would mess that up. So I have these 3 capacitors here are in series. If they were resistors, I would just add them up. But they're capacitors, so it's going to be 1 over 3 plus 1 over 6 plus 1 over 3. I can't do product over sum because there's 3 of them. So I have 1 over 1 over 6 plus 1 over 3 plus 1 over 3, or 2 over 3. Which is 1.2. So that's 1.2, that's 6, and that's 5. Well, now I can see that, from any perspective, the 6 farad capacitor and the 1.2 farad capacitor are in parallel. No matter any way you look at it, they're in parallel. And so I would, since they're capacitors, that means you just add them. So that becomes 7.2. Now I have 2 capacitors in series. It's just 2 of them. So I can say product over sum, 5 times 7.2, right? Yeah. 5 times 7.2 over 5 plus 7.2 is 2.95 farads. Let's see if I did my calculations correctly. 2.95, yay. All right, so now let's see what it is from the point of view of C and D. Now, from the point of view of C and D, This 5 farad capacitor is open. So it does not contribute to the capacitance. So I'm just going to redraw it without that one. So when you're doing one of these, when you go to figure it out, what you should have should be, when you want to be looking at a closed circuit, because the open parts don't contribute to the capacitance. Okay, so now I have these 3 in series, which is the same as what I had over here, a 3, a 3, and a 6. So that will be the same. That'll be 1.2. And then the 6 and the 1.2 are parallel, so I can add them. So that's 7.2. So far, that's the same. But now things are different, because now I have 3 capacitors in series. And so my equivalent capacitance is going to be 1 over... there's 2 ways. I'm going to do this. You can do them 2 at a time. And so since 2 of these are identical, I know that when I have 2 that are identical, the equivalent is just half. So that's 2.5. So I just did the 5 and the 5 together, and then that means now I have 2, and I can do product over sum. And did you do it?
Yeah.
What'd you get?
1.6.
That's what I got. Somehow I don't remember seeing that as the answer, but... $1.86?